In this video tutorial, I'll be showing you how to build an inexpensive and 3D printed visual reinforcement audiometry VRA box. VRA equipment is commonly used to test the hearing ability of young children, usually between the ages of 10 months to 2 years old. Let's get into the tutorial. Let's go over the 3D printed parts that we'll need for the VRA build. First, the largest part, the VRA mainframe. I still have the supports attached and we'll remove that shortly. Next, the LED holder. Next, the VRA top. The acrylic plate holder sliver. The main controller piece. The back cover plate. The toy platform. The controller faceplate. And the wire covers. There should be 2 of these. Now we'll go over the non-3D printed things that we'll need. We need some thin wire. I'll be using 5 different colors here. Shrink tubing, 4 5mm LED lights, the pin components used on Arduino projects. We'll need 5 of those. We need 2 resistors, one of them being 1 ohm and the other being 220 ohm. We'll need our Arduino Uno board, a rocker switch, a push button, a 9-gram micro servo, a female USB connector with a wire attached. We'll be cutting this later and not using the micro USB end. We'll also need a long male USB cable. I'm using a 10-foot cable here, and we will also cut the micro USB end off later. And finally, we'll need our programming cable that the Arduino Uno comes with. For this build, we'll also be using some small zip ties. 4 of them should be enough. We'll also use the acrylic plate from this 5" by 7" acrylic picture frame. I found this frame at a local dollar store. The acrylic panel that we'll be using should be no thicker than 1.5 millimeters. We'll also need some 80% window tint. And this is the kind of stuff that's used for car headlights. I'll post a link in the description for more information on these materials, screenshots, Amazon links, and alternatives. I'll be using a variety of tools for this build, including pliers, sharp picks, an X-Acto knife, some super glue, a soldering iron, and a glue gun. As one final optional step, I will paint the controller faceplate letters with 2 coats of Tester's white enamel paint. Let's start with the build. The first step is to remove all of the supporting material from the mainframe. There's lots of supports, and I'll start with this back cover by pulling it off. Next, I'll remove the supports in these holes. These holes can be used for wall mounting for your VRA device. Their size fits most screw heads and mounting devices. There's 3 very important pieces used to mount your Arduino Uno. One of them is up here, the other is this cylinder over here, and the last one is this cylinder over here. We want to remove the supporting material below these pieces. There are these rib-like parts along the sides here. They're important for our wire management when we wire the device up. We'll need to remove the supports in between these ribs. Let's now remove the support on the side of the device. This is where our power wire and the controller wire will exit from. An important wire feature for this device ensures that the wire cannot be pulled out of this back component. Right on the inside of this wall are small grooves, as you can see here. We'll be running twist ties through these grooves later to secure the wires. And now we'll just remove the supports under these grooves. I like to just run over all the edges with a blade to make sure that all of the supports have been removed. We'll flip the device over and remove the supports from where the servo will sit. Now I'll do one final run through with a knife to clean off any sharp edges. We'll install the servo in its slot on the VRA main frame. First, we cut the servo wire. I'll cut this wire so that there's about 12 centimeters of wire left. Now, we'll just separate these 3 colored wires about an inch. And I want to strip the ends of each of these wires because we'll need to solder other wires onto it later. It's easier to do this step now than to do it later. Once the wire is prepared, we'll feed it through the servo encasement first, and then through the small slot in the back wall. The servo can now be pressed firmly into its slot. Let's upload the sketch to our Arduino Uno. Plug the programming cable into the Arduino and plug the USB end into a computer. If this is your first time using an Arduino board, I'm going to link a guide on how to upload a sketch for you to follow. We should now have the code uploaded to the Arduino Uno. Next, let's mount the Arduino into the VRA box. First, feed the USB programming cable through the side hole of the main frame here and pull the wire through. We'll place those tiny cylinder parts on the main frame through the holes on the actual Arduino board. The Arduino should fit snug. If it doesn't right off the bat, don't worry. We're going to be using some hot glue later to help secure the Arduino to the main frame. Okay, we're going to do the lights now. For this, we'll need the LED holder piece, 4 LEDs, our 1 ohm resistor, soldering tools, black and red wire, and shrink tubing. We'll need to cut 4 strips of black wire about 8 centimeters in length. We'll do the same for red wire, 4 strips, 8 centimeters in length. And I'm going to expose both ends of all 8 wire pieces. Next, I'll add a bit of solder on each wire end. We'll now connect the wires we just made to the LEDs. All LEDs have a cathode and an anode. The cathode is the small piece of metal in the acrylic casing of the LED, and the anode is the large piece of metal in the acrylic LED casing. We want to always connect our black wires to the anode side and our red wires to the cathode side. In order to get our LEDs to fit nicely in the LED holder, let's first separate the 2 prongs and then bend them 90 degrees. Remember, always check the anode and cathode. Make sure you have the anode on the left and the cathode on the right when you look at it like this. Let's do this for all 4 LEDs. Next, we'll add some solder to each LED prong. Connect the red wires to the cathode and the black wires to the anode. The LEDs and wires will fit on the LED holder piece like this. Before we stick them on, I'm going to protect and cover each of the solder joints with some shrink tubing. I secure the shrink tubing by using the heat from my soldering iron. Now here's our 4 LEDs with their wires. To secure the LEDs to the LED holder, put down a glob of hot glue underneath the LED hole Then place the LED into the hole and press the wires onto the glue. Ensure that the LED is pointed down and is perpendicular with the LED holder piece. Do this for the other 3 LEDs. It's a good idea to do one last check that the anodes and the cathodes of each LED are correctly wired to the right wire color. Here's what we should have now. Let's link up all of our red wires now to look something like this. And we'll do the same for the black wires, link them all up. We'll grab our 1 ohm resistor and cut it down to size. And we'll tin both ends with solder. Solder one end of the resistor to the black wires like this. And this is what we should have now. We're going to need a red and black wire, each about 10 centimeters in length. Solder this new red wire to the red grouping of wires. And solder the new black wire to the resistor. Let's add some shrink tubing and we're good to go. We can test to see if our work is functional by taping 2 AA batteries together and putting the black wire on the negative terminal and the red wire on the positive terminal of the battery. And all is working well. Let's move on to the next step. For this step, we're going to super glue our LED holder onto the VRA top piece. There is an indent that the LED holder walls should fit into. We'll put some super glue on the LED holder and join the 2 pieces together. Make sure that the black and red wires are meeting in the middle and not getting stuck and jammed on those rails. These rails will be used to help keep the top onto the main body. We'll attach the VRA top piece to the VRA main frame. These rails in the center will interlock with the middle wall of the VRA main piece. I'll start by first putting glue down the middle wall, then putting glue on the sides of the top piece, then around the perimeter of the main frame. Super glue works best when used in small amounts. Place the 2 pieces together. Make sure that they're fitting nicely, and then put some heavy stuff on top and let the glue dry. While the glue dries on the main frame, let's prepare our USB cable. This cable will connect the mainframe to the VRA controller. We'll start by cutting off the micro USB end. We don't need that part, but we do need the group of wires inside this cable. About 15 centimeters from where we made our cut, we'll need to expose the wires within here. Being very careful not to damage the inner wires, gently slice the cable so that we remove the braided cover and the white cover underneath it. We should have 4 individual wires now, red, white, green, and black. Let's strip the ends of these wires and tin them with solder. The cable that I bought is braided, and since it's been cut, this braiding will eventually come loose. So I'll seal up that braid with some shrink tubing so that it never comes loose. Our cable is now complete. Let's feed the cable through the side port and pull it through. We will now secure the 2 cables to the mainframe with zip ties. This will ensure that all the internal electronics do not get ripped out if the cables are accidentally yanked on. We'll push one end of the zip tie through one of these slots. Making sure the zip tie goes underneath the 2 cables, let's bring the end of it up and pull it through the locking mechanism of the tie and tighten it. I'll be doing this with 2 zip ties. Trim off the excess zip tie, and now the two cables are very secure to the main frame. We'll secure the Arduino Uno board with hot glue. Pull the Arduino out and put a glob of glue on both of the tiny cylinders. Push the Arduino into place. Place some hot glue on this upper rectangular piece to ensure that the Arduino stays in place. We'll now make the wires that will connect everything together. We need to make 5 of them. These wires fit into the pin slots of the Arduino and connect all these other wires to where they need to go. This step will require our 5 color wires, shrink tubing, and Arduino pins. We'll start with the black wire, and this will be called wire number 1. Measure out 4 pieces of black wire, approximately 8 to 9 centimeters in length. Strip the ends of each wire and tin them. Grab one Arduino pin and solder a wire to the small end of the pin. I like to tin this small end first to make the soldering easier. We've soldered the pin to one wire end and it should look like this. Now we'll protect this area with some shrink tubing. Take the other 3 black wires and join them all together at one end. Solder these 3 wires to the other single wire. Be sure to put some shrink tubing in before so that you can protect this junction. Wire number 1 is now complete. For wire 2, we'll be using the red wire color. Cut 3 pieces of wire, each about 10 centimeters in length. Strip and tin each end of the wire. Solder an Arduino pin to the end of one of the wires. Solder the other 2 wires together as a bunch. These 2 wires will then be soldered to the other wire. Protect the junction with shrink tubing. Wire 2 is now complete. Wire number 3 will be made with the yellow color wire. This is a very simple wire. Just cut one piece of wire about 10 centimeters in length. Solder on an Arduino pin to one of the sides. Wire number 3 is now complete. Wire 4 will be made with the green color wire. This wire is exactly like wire number 3. Measure out one piece of green wire about 10 centimeters in length. Solder on an Arduino pin to one of the sides, and wire number 4 is now complete. Wire number 5 is our last wire. We'll be using the white color wire for this one, and we'll also need our 220 ohm resistor. Measure out 3 pieces of wire about 10 centimeters in length. Add an Arduino pin to one of the wire ends and protect it with shrink tubing as always. Grab our 220 ohm resistor and cut it down to size. Solder one end of this resistor to another one of the white wires. It doesn't matter which way the resistor goes. With our third white wire, solder it to the other side of this resistor like so. You want to bunch the wires like this. Solder our first wire to the 2 wires now, and protect the junctions with shrink tubing. Add another piece of shrink tubing to protect this resistor. Wire 5 is now finished. We'll connect up these 5 wires into the VRA box now. Before we install any of the wires, let's add a bit of solder to the ends of these 3 servo wires. Let's go ahead and grab wire number 4, the green one. This end of the green wire will be soldered onto the orange wire of the micro servo. Remember to place some shrink tubing before to protect the solder joint. Now let's go ahead and grab wire number 3, that's the yellow wire. This end of the yellow wire will be connected to the red wire from the LED lights. Solder those two together and protect the solder joint. Let's plug these wires into the Arduino. Grab wire number 3, the yellow wire, and plug the pin into the pinhole that's labeled 12 on the side of the Arduino. Tuck any loose wire underneath the ribs on the side. Grab wire number 4, the green wire, and plug the pin into the pinhole that's labeled 9 on the side of the Arduino. Again, tuck any loose wire underneath the ribs on the side. We'll grab wire number 2 now, the red wire, and we'll plug the pin into the pin slot labeled 5V on the right side of the Arduino. One end of wire number 2 will link up to the white colored wire from our controller cable, and the other end of wire number 2 will link up to the green colored wire from our controller cable. Solder these wires together and protect the junctions with shrink tubing. We'll also tuck these wires into the side ribs. We'll grab wire number 1 now, the black wire. Wire 1's pin will plug in directly above the red wire into the pin slot labeled GND. One of the wire 1 ends will be attached to the black wire from the LED holder piece. Another end of wire 1 will be attached to the brown wire from the servo cable. The last end of wire 1 will be saved for later. Let's first solder one end of wire 1 to the black wire from the LED holder piece. We'll also protect this junction with some shrink tubing. We'll then solder another end of wire 1 to the brown wire from the servo cable and protect the junction with shrink tubing. The last end of wire 1 will be saved for later. Let's grab our last wire now, wire number 5, the white wire. The pin for this wire will plug into the pin labeled 2 on the Arduino board. The end of wire 5 without the resistor attached to it will attach to the black wire from the controller cable. Let's solder that up and protect it with shrink tubing. The other end of wire 5, the one that has the resistor attached to it, will connect to the last end of wire 1 that we haven't used yet. Let's solder those up together and protect the junction with some shrink tubing. Take some time to tuck the excess wire into the side ribs. There's one more solder joining left to do here. Take the red wire from the controller cable here and join it with the red wire from the servo. Protect the junction with shrink tubing and tuck the wire into the side ribs. The wiring of the VRA mainframe is all done. Let's now move on to the VRA controller. For this, we'll need the main controller piece, the controller faceplate, our rocker and push button switch, shrink tubing, green, red, white, and black wire about 7 centimeters in length, 2 more zip ties, and our female USB cable. I'd like to start by shaving off any excess material on the outside of the controller faceplate, and I'm going to lightly sand and clean up the writing on the faceplate, because I'll be painting the letters white later on in this video. Let's grab our rocker switch and we'll clip it into place in the top hole slot. The rocker switch that I'm using has a tiny LED in it, but I won't be using this LED. For this specific variety of rocker switch, it's important that this tiny LED is at the bottom, so that the LED is closest to the word motor on the controller faceplate. I'm also going to firmly screw my push button into the bottom hole slot. I also want to pre-tin the button pins that I'll be using, which are the middle pin for the rocker switch, the bottom pin for the rocker switch, and both pins for the push button. The faceplate is looking good. Let's put that aside and grab our controller main piece. We need to remove all of the supports on the main controller piece, including the back slot here for the wire that connects to the mainframe, and also the support on the inside of the controller box here. I go over the edges with a knife to remove all the excess material. Grab the USB female connector cable and cut off the micro USB part that we do not need. Let's strip the ends of this cable, being careful not to damage the inside wires. This cable that I'm using is pretty short, so I'm going to strip the ends of each wire and extend them a bit with the extra wiring that we have. Now that our 4 colored wires are a little bit longer, let's feed these wires through the cable entrance on the outside of the controller box like so. We want to secure this cable to the controller box with our zip ties as a safety feature. That way, if the cable ever gets accidentally pulled on, the electronics stay put and won't get ripped out of the controller housing. We'll grab a zip tie and feed it through one of the side slots on the controller main piece. Wrap the zip tie around the cable and tighten the zip tie. We'll do this with another zip tie too, and then cut off the excess material. Let's connect and solder these wires to the controller faceplate buttons. I'm just putting down some shrink tubing on each wire ahead of time. The controller faceplate should fit on the controller main piece like so. Flip over the faceplate and let's start by soldering the black and white wires to the push button. Solder the black wire to one of the push button pins, then solder the white wire to the other push button pin. It doesn't matter which pin each color wire goes onto. Protect these junctions with some shrink tubing. Let's solder the green and red wires to the rocker switch. Solder the red wire to the outside rocker switch pin. Then solder the green wire to the middle rocker switch pin. Protect these junctions with shrink tubing. The faceplate can go on top of the main controller piece, but before we superglue the two parts together, let's do a test to ensure that these controller buttons work correctly with the VRA box. Grab the VRA box and plug the long controller cable from the VRA box into the controller. Grab the shorter blue programming cable and plug it into a power source. Either a computer or a wall charger should work. To ensure that the device is correctly powered, look at the Arduino and the green power light here should be on. A press of the push button should turn on the lights. Setting the rocker switch to the on position should make the servo turn and the lights turn on when the push button is pressed again. Since everything works well, we can now superglue the faceplate to the main controller piece. Let's now install our two wire cover pieces. One wire cover has two circular indents like so, and this one goes onto the VRA main box. The other wire cover piece has one circular indent, and this one goes onto the controller. Take the controller wire cover and clip it into the hole where the wire comes out from on the controller piece. There's no need for super glue here, as this cover piece fits very firmly into its slot. Grab the VRA box and clip the other wire cover into the wire slot on the side of the device here. Let's install the toy platform enclosure piece now. There's a small hole indent on the bottom of this platform, and this fits snugly on the white servo gear. Push the platform onto the servo firmly, no glue needed. Let's grab our backplate and install it. The backplate has an outdent that snugly fits in the large hole on the back of the VRA device. Clip this piece into place by pushing the plate corners in. Some bending of the plate may be required. We're on to one of the final steps in this tutorial, creating the tinted acrylic faceplate that hides the VRA toy when it's not lit up. Grab the 5x7 acrylic picture frame, and it's time to cut it to size. The 5-inch width of the picture frame will fit the VRA box slots perfectly. For the length of the acrylic plate, we need to cut the acrylic piece to be 16.1 centimeters long. I used a Dremel to cut both ends of the picture frame off, but a circular saw, a bandsaw, or even a jigsaw would do the job too. Let's add our tint to the acrylic plate. We're using stick-on tint, so make sure your workspace is free from dust and debris. Grab your acrylic plate and clean it off with a cloth to remove any fingerprints and residue. Cut a piece of tint to size. You should cut the piece to be a bit bigger than your acrylic plate, about 1 to 2 centimeters on each side, then we can trim the extra material off after. Peel off one end of the tint and stick the sticky end onto one side of the acrylic plate. As you apply the tint to the acrylic plate, use a plastic spatula or a credit card to ensure no bubbles get trapped under the tint film. Take your time with this step. If you get a bubble trapped, you might have to restart with a new piece of tint. Once the piece of tint has been applied to the acrylic plate, cut the excess material off with some scissors. Grab the VRA main box and slide the tinted acrylic plate into the side slots like so. We want to hot glue the top sliver piece to the top of the acrylic plate now. Apply hot glue to the top of the acrylic plate, then push the top sliver piece onto the acrylic plate. The top sliver has a rail that will lock with the acrylic plate, and now the two pieces are joined. As one final optional step, I will paint the controller faceplate letters with 2 coats of Tester's white enamel paint. And there we have it. This has been a tutorial on how to make a cost-effective and 3D printed visual reinforcement audiometry box. These boxes can also be linked up and used in tandem in case one box isn't enough.